Hi friends, good morning. Please look at the next problem. This is problem number 18. Problem number 18 of exercise 15.1 of chapter probability. Friends, look at the problem. See, a box contains 90 discs. A box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it is a two-digit number and then it is a perfect square and then its number is divisible by 5. So here total number of outcomes are 90. We have 90 numbers from 1 to 90. We have 90 numbers from 1 to 90. So total number of outcomes is 90. That is ns is equal to 90. Now first thing we want the number is a two-digit number. Let E1 be the event of a two-digit number. Let E1 be the event of getting a two-digit number. So how many two-digit numbers will be there? How many two-digit numbers will be there from 1 to 90? 1 to 90 means there are total 90 numbers, but from 1 to 9, one digit numbers. So favorable outcomes is equal to 90 minus 9, that is equal to 81. Now the probability of getting a two-digit number is equal to, now NE1 is equal to 81. Now probability of getting a two-digit number, that is P of E1. P of E1 is equal to 81 favorable outcomes by total number of outcomes 90, that is equal to 9 nines, 9 tens. 9 by 10 is the required probability. So that is first question, friends. Getting a two-digit number. And the second question, the number is a perfect square. See how many perfect squares will be there. From 1 to 90. So let E2 be the event of getting a perfect square. Let E2 be the event of getting a perfect square. Then n of E2. How many perfect squares? That is favorable outcomes. How many perfect squares are there? 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, and 9 square. 81. So how many outcomes are favorable? 3 plus 3 plus 3, 9 outcomes. 9 outcomes are favorable. That is, in the case of these are 9 perfect squares are there from 1 to 90. So probability of getting a perfect square P of E2, that is equal to NE2 by NS. That is equal to, NE2 is 9 by 90, that is equal to 1 by 10 is the required probability. And third question, number is divisible by 5. That is a multiple of 5. How many multiple of 5s are there from 1 to 90? That is simple. 18 5s are 90. So you will have 18 multiples of 5. So let E3 be the event of multiple of 5 or divisible by 5. Then n of E2 then n of E2 is equal to 18. 18 fives are 90. 18 fives are 90. So you will have 18 multiples, 18 favorable outcomes. That is 5, 10, 15, 20, 25, 30 up to 90. You will have 18 multiples of 5. So favorable outcomes 18. Favorable outcomes 18. Of course, total number of outcomes 90. Now the probability of getting a multiple of 5, that is PE3. PE3 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 is equal to 18 Ne3 by Ns, that is equal to 18 by 90, that is equal to 1 by 5 is the required probability. Okay friends, thank you. Have a nice day. Hi friends, good morning. Please look at the next problem. Friends, this is problem number 17 of exercise 15.1 of probability chapter. Okay friends, a lot contains 20 pence. A lot contains 20 pence and of which 4 are defective. So total number of pence lot contains 20 pence and it contains 4 defective pence. So defective pence 4, and then non-defective are 16 First, your first question is a pen is drawn at random. Then what is the probability that it is defective? So total number of outcomes ns is equal to 20, that is clear, and let the event favorable outcomes for the event being defective, say n of defective are 4, because we have out of 20 we have 4 defective bulbs. So number of favorable outcomes 4. Then probability of the bulb being defective is equal to n defective by total number of bulbs, that is equal to 4 by 20, that is equal to 1 by 5 is the required probability. Then look at the second question. If the bulb drawn in the first draw is non-defective and not replaced. See, non-defective and not replaced. See, then total number of pens, that is ns becomes, see, the pen is not replaced. So then the total number of outcomes becomes 20 minus 1, 19. And favorable outcomes. Then what is the probability that the bulb is non-defective? Friends, in the second draw, it is found that the bulb is non-defective. And is not replaced. So number of non-defective bulbs will get reduced by 1. So then non-defective bulbs is equal to 16 minus 1, that is equal to 15. So n of non-defective is equal to 15. Now we want, one bulb is drawn at random. What is the probability that the bulb is non-defective? How many non-defective bulbs we have? First we have 16 non-defective bulbs, but one non-defective bulb is drawn and is not replaced. So number of non-defective bulbs will get reduced by 1, and the total number of bulbs also will get reduced by 1 because it is not replaced. So then the total number of bulbs become 19 and total number of non-defective bulbs becomes 15. Now one bulb is drawn. What is the probability that the bulb being non-defective? That is P P of non-defective, P of non-defective is equal to N of non-defective by NS 15 by 19 is your answer, friends. Okay friends, thank you, have a nice day.